Modeling complex reservoirs with, for example, Y-shaped or reverse faults can be a difficult task using traditional modeling tools. Since PETREL 2010, we can represent a watertight structural framework built from the seismic interpretation objects and still keep all the complexity. However, we need to convert it to a grid for property population and dynamic simulation. In PETREL 2011, we introduced the full stair-stepped grids that allow representing the structural complexity of the 10 to 15% of reservoirs that struggle to be represented by pillar grids. With one single process, you can create a structural grid from a structural framework, streamlining the interpretation to modeling and simulation workflow. We are here looking at a structural framework that was built using the modeling while interpreting tools in PETREL. A structural framework contains the representation of the faults and horizons in the field, and can be much larger in size than the final reservoir model you intend to produce. If we look at an intersection cutting the structural framework, you can see the fault framework here is quite complex, with crossing faults, various truncations, and fault connections. To create a full stair-stepped grid from that structural framework, all you need to do is to run the new structural gridding process. This process is equivalent to the fault modeling, pillar gridding, make horizons, make zones, and layering processes all together in a traditional pillar grid workflow. After you open the structural gridding process, give your new grid a name. Then, using the blue arrow, drop in the structural framework that contains the horizons and faults you want to include in your reservoir model. For the vertical interval, select from the table the horizons you want to use, and if you want them to represent region boundaries. On zone layering, you define the layering style and the number of layers per zone, here 100. In the Geometry tab, you set up the size of your grid. You can do so by dropping in a closed polygon. The polygon will usually limit your area of interest and can decrease a lot the number of cells in a model. For the cell lateral increment, just type the cell size. Here we're using 50 by 50 meters. You can also select the grid rotation, in our case 65 degrees. In the Faults tab, you can decide which faults you want to include in the final grid. After all faults are selected, you can run the process. The resulting stair-stepped grid contains all faults represented by IJK cell walls. The grid is now ready for property population using the geometrical, fasces, or petrophysical modeling processes, as well as for fault ceiling analysis with the structural and fault analysis module. This type of grid is also very simulator-friendly due to the cell orthogonality. While you commit to keep all the complex structural geology of the reservoir, you'll still deliver a grid that can be carried on to simulation in eclipse or intersect with little effort.